Hey guys, so here are the notes for 4.9. In these notes, we are going to graph quadratic inequalities and give a shade region as the solution. So you guys have learned, basically like in Algebra 1, when you guys did linear inequalities, basically graphing those. And that's where you had to figure out, which way, first graph the linear inequality, then figure out if that line is going to be solid or dashed, and then there's going to be shading. We're going to be doing the same thing here, but now just with quadratics. So we have 4 different ways that we could have a quadratic inequality, because we have the less than or equal to, greater than, and the greater than or equal to signs. Now, anytime when we are having an equal bar underneath our inequality, we are going to have a solid parabola. So basically, it's going to look like this. So remember, either your problem is going to open up or it's going to open down. Now, there is no equal bar underneath your inequality here. Then we're going to have a dashed parabola. So it's going to look something like this or something like this. Okay? Okay, so let's go ahead. We're going to do our first example. You might see there is more stuff like talking about how to graph. I'm going to kind of go explain this while we are doing the problem. Okay, we're going to do our first example, which is y is greater than x squared plus 2x minus 8. Now notice what form this is in. This is in standard form. Okay, so we are going to graph, and we're going to use what we have learned on how to graph quadratic in standard form. So the very first thing that we need to do is figure out the vertex. Okay, remember, to find the x value in standard form of the vertex is when we do opposite of b over 2a. So we have b as 2, so the opposite would be negative 2, and we have 2 times 1. So we're going to have negative 2 divided by 2 gives us negative 1. Now remember, to find our y value, we're going to plug that negative 1 back into the x. So here I am going to do y equals, because we are trying to solve for a y value. I have negative 1 squared plus 2 times negative 1 minus 8. And you can just plug that into your calculator all as you see it, exactly as you see it here, especially with the parentheses, and we should get negative 9. Okay. So now, once we have found the vertex, we're going to go ahead and do our xy table. So remember, when we do our xy table, we have the vertex that's in the middle. Then we pick 2 x values that are smaller, so like negative 2 and negative 3, and 2 x values that are bigger, so like 1 and 0 and 1. Now you only need to plug 2 into these, into our inequality here. So what we're going to do is I'm going to plug in 0 and 1 to get those y values, because that's going to be a lot easier, okay? So don't forget how you can plug this into your calculator. I'm going to kind of show you here now. Okay, let's go ahead and do it with the calculator here. I'm going to plug 0 into our quadratic. So I have, there we go. I'm going to do parentheses 0, and then we square it, and then we have plus 2, parentheses 0, and then we'll have that minus 8 there. And make sure you do minus 8. And that's going to give us negative 8, right? Okay. So we have negative 8. Now you do the same thing with 1. So you do the exact same thing. And when we do, we get negative 5. So now we have negative 8 and negative 5 here. Okay, now before we graph these points, let's kind of talk about, is this going to open up or open down our quadratic? Hopefully you said it's going to open up because our a value is positive. So let's go ahead and plot these points. And notice what our y-intercept is here. So we figured it out actually on our xy. So remember, when you plug 0 in for x, then whatever your c value is, which in this case negative 8, that's going to be our y-intercept. And we can see that it crosses the y-axis at that negative 8. Now before I draw my parabola, I got to figure out, is this going to be dashed or solid? Well, notice here that our inequality does not have an equal bar. So we are going to have a dashed parabola. Now, when you are graphing these, make sure that your arrows go off the graph. And the reason is because we're going to shade. So it just kind of makes it easier to know where you need to shade when your arrows go off the graph, okay? Now, our last thing that we need to do is we need to create a test point. testing point, we will decide if we're going to shade inside or outside the parabola. So when you are doing this, pick a test point or any point that is inside the parabola. So this testing point can't be on the parabola itself. It needs to be something that is on the graph. So I would just suggest always pick a point that is inside the parabola. So the easiest point to use would probably be 0, 0. So we're going to go ahead and do that. And notice 0, 0 is not on our parabola, so we can use that as a testing point. Okay, so we have 0 for x and 0 for y. We're going to plug those into our inequality here. So we have 0 is greater than 0 squared plus 2 times 0 minus 8. So notice I put 0 in for y and for x. So now I have 0 is greater than negative 8. We need to decide, is this a true or false statement? It is true. So because it's true, we shade where the testing point is at. And basically that what means is we're going to shade inside the parabola. Okay. I'm going to go ahead and do that. That's why it's important to kind of basically have your arrows that is off the graph. Okay. Okay, make sure you watch the next part. It's just going to be more examples of graphing quadratic inequalities.